Hello everybody, welcome to a new video of my channel of physics with Argel. Today we are going to solve the problem 35 of the book Physics, Concepts and Applications of the very respected and excellent Professor Paul E. Tippens of the Department of Physics in Chairperson. The problem is the next. What must be the separation between two charges of negative 4 microcoulomb if the repulsive force between them is 20 Newton. The force by the law of Coulomb is K multiplying Q prime divided by R squared. Then the force multiplying R squared is equal to K multiplying Q prime. Then R squared is equal to Q prime divided by F. And then the square root at both sides of this equation is R equal to the square root of Q prime divided by R by F. This is R. So the force, the electrical charges, and the constant of Coulomb are known. So the square root of 9 multiplying 10 at the 9th power newtons meter squared divided by Coulomb squared is equal to the constant of Coulomb K. Now, the magnitude of the electrical charges are 4 times 10 raised to the power of negative 6 Coulomb, multiplying 4 times 10 raised to the power of negative 6 Coulomb, divided by 20 newtons. It's equal to the square root of 9 multiplying 4, 36. 36 multiplying 4, 144. 10 raised to the power of 9 plus negative 6 is 10 raised to the power of 3. And multiplied by 10 raised to the power of negative 6 is the sum of the exponents. So 3 plus minus 6 is equal to negative 3 divided by 20 newtons. Coulomb multiplied by Coulomb and divided by Coulomb is equal to 1. It's equal to 144 divided by 20 is equal to 7.2 times 10 raised to the power of negative 3 meters squared. It's equal to the square root of 7.2 multiplied by 10 is 72. But if I multiply by 10, I also have to divide by 10. So 10 raised to the power of negative 3 divided by 10 is 10 raised to the power of negative 4 meter squared. Now the square root is applied on each other of the factors. So the square root of 72 multiplying the square root of 10 raised to the power of negative 4 is 10 raised to the power of negative 2. And the square root of meter squared is equal to meters. Now, we have to do this procediment to calculate the square root of 72. 72 divided by 2 equals 36. 36 divided by 2 equals to 18. 18 divided by 2 equals 9. 9 divided by 3 equals 3. And 3 divided by 3 equals 1. So, we have to look at these numbers. So, 2 multiplying 2 multiplying 2 multiplying 3 and again multiply by 3. So it's equal to 4 multiplying 2 multiplying 9. But 4 and 9 have square root. So the square root of 4 is 2 and the square root of 9 is 3. 2 multiplying 3 is equal 6, and this last number 2 is an irrational number. So we have to write just the square root of 2. Multiplying 10 raised to the power of negative 2 meters. Now this is the number that we are going to use in this problem. This is approximately equal to 8.49 times 10 raised to the power of negative 2 meters. It's equal to 84.9 times 10 raised to the power of negative 3 meters. Because 8.49 multiplied by 10 is 84.9. But if I multiply this number by 10, I also have to divide this number by 10. So 10 raised to the power of negative 2 divided by 10 is equal to 10 raised to the power of negative 3 meters. It's equal to 84.9, and 10 raised to the power of negative 3 is the same than milli. So millimeters of distance, because this is r equal to r. Now we have to check it. So by the law of Coulomb, the force is equal to K multiplying Q prime divided by r squared. Now K has this magnitude, 9 times 10 raised to the power of 9 Newton meter squared divided by Coulomb squared, closed by parentheses. Now the electrical charges have these magnitudes, 4 times 10 raised to the power of negative 6 Coulomb multiplying 4 times 10 raised to the power of negative 6 Coulomb divided by the distance, and this distance is this one, 6 times the square root of 2 multiplying 10 raised to the power of negative 2 meter squared. Now I have to multiply these numbers of black, and then multiply these numbers of red, and then multiply these units of blue. So 9 multiplying 4, 36, and 36 multiplying 4, 144. 6 times the square root of 2 squared is equal to 6 squared multiplying the square root of 2 squared. And this is the next. 6 squared closed in parentheses multiplying open parentheses the square root of 2 closed parentheses squared. It's equal to 6 squared 36 multiplying the square root of 2 squared is just 2. So 36 times 2 equals 72. So divided by 72. Now the product of the numbers of red is the sum of the exponents. So 9 plus negative 6, 3. And 3 plus negative 6, negative 3. This divided by 10 raised to the power of negative 2 squared. But 10 raised to the power of negative 2 squared is equal to 10 raised to the power of negative 2 multiplying 10 raised to the power of negative 2. It's equal to 10 raised to the power of negative 2 plus negative 2 equal negative 4. Like it appears here. So, Newton, now we have to multiply the units of blue. Newton meter squared multiplying Coulomb by Coulomb squared divided by Coulomb squared meter squared. Now, 144 divided by 72 is 2. 10 raised to the power of negative 3 divided by 10 raised to the power of negative 4 is the next. We have to raise negative 4 to negative 3. So, 10 raised to the power of negative 3 divided by 10 raised to the power of negative 4 is equal to 10. I write 10, then I write negative 3 closed by parentheses, then the symbol of raised, and then open parentheses, negative 4. It's equal to 10 raised to the power of negative 3 minus 4 equal 1. So, 10 raised to the power of 1. Now, Newton meter squared Coulomb squared divided by Coulomb squared meter squared, these units are equal to 1. So, the next unit is Newton, equal to 2 times 10 raised to the power of 1 Newton, equal to 20 Newton of repulsive force. This result is equal to the result of the start. So, this means that this result for the distance r is correct, because using the law of Coulomb with this distance, I obtained the same force that the problem establishes. So, students, it was the problem 35 of the book Physics, Concepts and Applications of the very respected and excellent professor of physics, Paul E. Tippens, of the Department of Physics in Chairperson. Thank you for your attention. In the next video, I'm going to solve the next problem and study a lot.